Everything around you, your desk, your drink, even the air you breathe, is made of tiny particles you can't see. A particle is just a tiny piece of matter, like a super small building block that everything is made from. Particles are so small you'd need a powerful microscope to even get close to seeing one. But scientists know particles exist because of how solids, liquids, and gases behave. This is called the particle model of matter, and it helps us explain the three states of matter. Let's start with solids like a block of wood or a metal spoon. In a solid, the particles are packed tightly together in a fixed, regular pattern. They can't move from place to place, they just vibrate on the spot. That's why solids keep their shape and don't flow like water does. Solids also have a fixed volume, meaning they don't spread out or squash easily. Now, let's look at liquids like water, juice, or oil. In a liquid, the particles are still close together, but they're arranged randomly, not in neat rows. These particles can move and slide past each other, which is why liquids can flow. That's also why a liquid takes the shape of whatever container you pour it into. But like solids, liquids have a fixed volume. They don't expand to fill all the space around them. Finally, let's talk about gases, like the air around us or steam from a kettle. In a gas, the particles are spread far apart, with lots of empty space between them. They move quickly and randomly in all directions, bouncing off each other and their container. This is why gases can spread out to fill any space they're given. Gases don't have a fixed shape or a fixed volume, they just expand to fit their surroundings. So the big difference between solids, liquids, and gases comes down to two things: particle arrangement and particle movement. The closer together the particles and the less they move, the more solid-like the substance is. Heating a substance gives its particles more energy, making them move and vibrate faster. That's exactly what happens when ice melts into water or water boils into steam. The particles themselves don't change, only how closely packed and how fast they're moving changes. Understanding this particle model helps explain so many things in chemistry, from melting metals to boiling water. Next time, we'll explore what actually happens during melting and boiling and why they need energy to happen.